All right, in this lesson, I'm going to talk about the graph of the function y is equal to tan x. Now, the graph of y is equal to tan x actually looks really different than from the graph of y is equal to sine x and cos x because it doesn't actually model a sine wave. So I'm going to show this graph here in just a moment here. Before I do anything, I actually want to generate some points on this graph. So you'll notice in my table of values on the right-hand side. I'm going to generate some points for the positive x values, okay? And then we're going to use the pattern to show the negative values last, okay? So it is still a periodic function. So let's go ahead and generate some points here. The first point I'll generate is the tan of 0 degrees, making sure you're in degree mode in your calculator, and you're going to get a y value of 0. So I'm going to fill in my table here. And then you have the tan of 45 degrees, and that's going to give you a value of 1. Okay, so the same process here for the tan of 90. However, when you put this in your calculator, it's going to say there's an error. Now, why is there an error when you put in the tan of 90? Recall the unit circle here. So the tan ratio for any angle in the unit circle is given by the formula y is equal to x. Okay, so let's look at 90 degrees. 90 degrees is right here, so pi over 2 in radians. Now, if I try to calculate the tan of 90 degrees, what we'll get is the y coordinate, which is 1, over the x coordinate, which is 0. Now, you can't divide by 0. This can't happen. So that's why we have NPV. There's an NPV at x is equal to 90 degrees. So it's non-permissible, meaning at a non-permissible value, you actually get a vertical asymptote. Okay, so we don't have any, there's a point of discontinuity, there's a vertical asymptote. Now, so anywhere on the unit circle where the x coordinate is equal to 0, that's where you're going to have some vertical asymptotes on this graph. So we found the first angle between 0 and 360. That's at 90 degrees. The next point where x is equal to 0 is right here, and that angle is given by 270, or 3 pi over 2. Okay, and then the next angle after that will be 90 degrees. So every 180 degrees, you'll notice that the tan function is not defined. So therefore, on my graph, every 180 or pi radians, you're actually going to see a vertical asymptote. Okay, so I'm going to go to my table of values here. For 90 degrees, you actually have to put in the fact that it's not defined. Okay, so we have undefined here. Okay, and actually my values seem to have disappeared, so I'm going to put in the tan of 0 is 0, the tan of 45 was, of course, 1. Okay, so if we continue this pattern here, we'll put in the tan of 135, and that's going to give you -1. So now we're getting some negative values here, and then the tan of 180 is going to give you a value of 0 degrees. So here's the next 0, and then the tan of 225 is going to give you 1. So as you can see here, we're repeating a pattern here, okay? So this pattern is going to look like this. Well, at 270, we have undefined, okay? Then we have a -1. Then we have a 0. That's what the pattern is, okay? And that's actually going to be the same thing for the negative values. So for the negative values, since -360 and 0 are both coterminal, they're going to have the same tan value. And the tan value is 0 here, -315, 1, -270, right? So that's coterminal with 90, has an undefined value. Okay, -1, 0, 1, undefined, and finally -1. So that's all the points I'm going to show in this graph here. And what I'm going to do is I'm going to plot these points. Before I plot them, I actually want to show the vertical asymptotes. So the vertical asymptotes are every 180, starting with, of course, the 90 degrees there. So we have a vertical asymptote at 90 degrees. So show a vertical line. I'm going to use a dotted line because they're asymptotes, right? So not actually going to go through that line. And then we have another vertical asymptote at 270. Okay, so this is periodic here. Another vertical asymptote for working in the negatives here, -270, and then -90 degrees. Okay, so they're all evenly spaced. It's periodic that way. So I'm going to go ahead and plot these points, and I'll be back. All right, so I plotted the points here, so you'll see all my blue dots here. We're actually going to connect the dots now. So remember, asymptotes are lines that the graph approaches but doesn't necessarily, well, it doesn't touch it, right? So I'm going to start from this point on the negatives here. I'm going to show this line. It's going to be curvy here, and it's going to approach that asymptote but not cross it. Then over here, well, it's going to start from down here, approach the asymptote, then go through that point, and then just like that. Okay, so it's looking a little wonky. And then same thing here. Okay, and then same thing here. As you can see, it's still approaching it, right? And then like that. So it's a little bit of a weird graph, and I apologize. I actually did not make it very nice for you, so I'm going to fix that up for you guys. But it's essentially curving. Okay, so it's curving, approaching the asymptotes that way. Okay, so this is what my graph looks like. I tried my best here to generate this graph, and the best I can do right there. Your book actually has a really nice diagram in there, so please check that out. I just want to show you where the points came from. Okay, so as you can see here, I have asymptotes every 90 degrees, right? Asymptotes every 180 degrees, starting with 90, right? So my asymptotes are every 180 degrees starting with 90. Okay, so plus 90 degrees plus multiples of 180, and to show multiples of 180 I'm going to multiply it by k, where k is a member of the integers, because you can also go in the counterclockwise direction as well. So those are where my asymptotes are. Let's talk about the zeros. So the zeros, as you can see here, occur at 0, 180, and 360. So that's also repeating. That is the x-intercepts are occurring every 180 degrees, but this time starting with 0 degrees. So to show that as a general solution, you start with 0 degrees and you add multiples of 180 in both directions. So multiplying it by k, where k is a member of the integers, but we don't actually have to show this 0. So our x-intercepts are every 180 degrees. So that's what my graph looks like there. It's very curvy. It's still periodic, and indeed, that's the last thing I want to mention here is the period of this graph. How often does it start repeating? Well, it repeats itself every 180 degrees. So my period is 180 degrees, or I guess in radians that would be pi. Okay, so that's the period of a tan graph. It is 180 degrees, so very different from the sine and cosine graph. So that's what the tan graph is all about.